I've made this recording to help you with part D and E of question 1 on the LV02.1K written assessment. So part D, as you can see here, is state the main advantage of an overhead cam arrangement compared to an overhead valve arrangement. So the first thing I want to do is to show you some images so that you have a visual understanding of the difference between overhead valve and overhead cam. So let's have a look at that. Now this picture here, as you can see, is overhead valve. Okay, so on an overhead valve engine, the camshaft is usually very close to the crankshaft, and you can see this is gear driven. On a lot of engines they'll have a short chain, so there'll be a timing chain. But the camshaft is quite a long way from the valves, which are at the top of the engine. So what we need to do in order to link them mechanically, we need these push rods. And just to give you an idea of what an actual engine looks like, I've got another picture here coming up. And this is an old Ford engine. It's very similar to the one that we have in our workshop, and most of you would have worked on to practice adjusting valve clearances, etc. In fact, I've got another image there. That's the same engine, but we've taken the rocker cover off, and if you remember, these are the valve clearances that you guys have all had a go at adjusting. So on this engine, the camshaft, if you imagine, obviously part of the image is missing, but if you imagine the camshaft is down here somewhere, and the push rods transmit the sort of movement from the camshaft up to the rocker arms, which are around about here. Okay, so that's an overhead valve engine, bit of an old-fashioned system, but it's still, on some engines you still see it around. Let's have a look at the next type. Here we've got an overhead cam diagram, so OHC, overhead camshaft. And in this image you can see the camshaft up here, and it is, as it says, it's over the head of the valve. So it's the overhead cams are usually at the top of the engine, and you can see it's sort of over the top of the valve and pushing the valves open. This diagram here is another type of overhead cam. So the camshaft is here, again at the top of the engine, and this one just has some rocker arms. Basically that allows us, you can see that these valves are on a slight angle, whereas these are sort of vertical. So it's just a different kind of arrangement, but essentially the same concept. The camshaft is at the top of the engine, and so that you can think of or visualize that in an engine that you've worked on. This is a Ford Z-Tech engine, and is very, very similar to the ones that you've worked on in the workshop. It's the task where you had to take the camshaft, remove and install a camshaft. So you can see actually in this engine that the bearing caps have been removed on both of these camshafts. Right, so this is an overhead camshaft engine. The camshaft is at the top of the engine. So let's put those two drawings side by side. So this is the overhead valve, older style. This is the overhead cam, more modern style. Now the question is, what are the advantages of an overhead camshaft? Well, the main one is to do with mechanical losses. Let me just explain that. So what we've got to do is, on this older system, we've got to transfer the movement that's caused by the camshaft lifting this valve lifter up and down, and we've got to transfer it up to the valve itself. So we need the valve lifter, or the cam follower it's sometimes called, which is resting on the top of the camshaft. So we have a point of contact here, and wherever there's contact between two components, there's going to be some friction. So we have a point of contact here. We then have the push rod itself, which sits and rests on the top of the cam lifter. So again, another point of contact and another area where there'll be friction generated. The other end of the push rod is pushing against the rocker arm, so there's another contact area here, and there'll be more friction. The rocker arm itself is on this rocker shaft, so the rocker shaft goes through the rocker arms, and these act a bit like a seesaw. They pivot backwards and forwards, and they have to move on the shaft. So there's friction between the shaft and the rocker arm itself. And then finally, we've got the point of contact on this end of the rocker arm, which actually pushes the valve open. So we've got 1, 2, 3, 4, 5 points of contact. And each one of those points of contact, contact between two different components, there is going to be friction, which means there are mechanical losses. The engine will be less efficient because some energy is converted to heat energy by the friction. Compare that to this one over here, the overhead camshaft. And the overhead camshaft, the cam is pushing on the cam follower, which then pushes the valve down. So there's really just that one point of contact here. Okay, so because there's only one point of contact, much fewer or much less friction is generated, so much less mechanical loss. So this system mechanically is much more efficient than this system. Okay, let's move on to part E of question 1. Part E says state 3 advantages of using a multi-valve arrangement compared to a single inlet and exhaust valve. So again, what I'd like to do is show you a diagram of a multi-valve arrangement. So we've got a drawing here, and you can see, let's say these are the inlet valves and these are the exhaust valves. So there are 2 of each, so it's multi-valve. Rather than just having a single inlet valve and a single exhaust valve, we've got two of each. So what are the advantages? Well, number 1, having a larger valve area, so having 2 valves instead of 1, means we can get more gas flowing in, so more air and more fuel coming into the engine. And by definition, if you've got 2 exhaust valves, you can get those exhaust gases out quicker. So if we can get more air and fuel in quickly, more air and fuel means more power, basically. So if we, as I say, the volume, if we increase the volume of air and fuel in, we are going to generate more power. The other, another advantage is if we were to have one big inlet valve, which would allow a decent amount of fuel and air in, the problem would be by having a single valve, the single valve would actually be much heavier. And we've talked about inertia forces in previous lessons. And if you remember, inertia force is the result of mass times acceleration. So the heavier a component is, the more inertia force it is subjected to. What that means is it's more difficult to get it to speed up and slow down, change its speed, or change direction even, make it open and close. A heavier object is much more difficult to A, get going, and then B, stop. So there would be a limit to how fast a large single valve could move. Having 2 smaller valves allows a large surface area, so that means more air and fuel can get in. But because the individual valves are smaller, they have less mass, they can move faster. So we can actually get our engine to rev much higher or quicker, and it'll be more responsive. So when you put your foot down, the engine picks up quicker. So it's a nicer experience to drive. So there's 2 advantages. First one is a larger volume of air and fuel can get into the engine, and that the valves can speed up quickly, slow down quickly, so they're more responsive. The final reason, or final advantage, is that having this kind of arrangement, as you can see in this diagram where we've got a slight angle, with the 4 valves, we can position our spark plug right in the middle here. Obviously, this diagram doesn't show the combustion chamber or a spark plug, but as I say, you can position your spark plug right in the middle, which means the point of ignition, where the spark is right in the center of the combustion chamber, which means you get a nice even flame spread right throughout the combustion chamber. So it just allows you to design the combustion chamber so that you can centralize the position of the spark plug. Okay, so there's 3 distinct advantages. Hopefully that will help you answer the question. Okay, I'm going to sign out there.